So we've been graphing parabolas for a while, and today we're going to be writing a vertex form quadratic function given the parabola. Okay, so I'm going to give you the graph of a parabola. You already have that worksheet, and we're going to look at the graph. We're going to write this vertex form function, quadratic function, and all you need to do is identify the a, the h, and the k, and then you simply plug it in right there, right there, and right there, and you'll have your vertex form quadratic function. Let's jump right in. So, I don't know, which one should we do? Just in order? Yes. Okay, let's do number one. Let's identify the a value. Okay, so does this have the pattern 1, 1, 2, 4, 3, 9? Does it have the pattern? No, it does not, right? So if we look at it, instead of 1, 1, well, it went 1 over and less than 1. So technically, that right there is your a value. So what do you think your a value that's less than 1 actually is if it looks perfectly in the middle? 1/2, right? So, and it is opening up, so it is positive. So we really have a is 1/2, okay? And if you wanted to double check it, like if a is really 1/2, then instead of going 2, 4, it should be going 2 and then half of 4, which is 2. And it does. It goes 2, 2, right? So we know that the a value is 1/2. Now, how about the h and k? It's as simple as identifying that location, the vertex, and that is -2, 0. So we know that our h value is -2, our k value is 0. So now we could plug it all into y equals a parentheses x minus h close parentheses squared plus k. I always recommend rewriting it with blank spots and then actually plugging in your a value of 1/2 right there, your k value of -2 right in there, and your k value of 0 right over here. So this is your equation. If it were a multiple choice test, you wouldn't see the +0 because +0 doesn't change anything. But there's your equation to this parabola. It does say state the axis of symmetry, the y-intercept, and the range. It's really easy to state all that stuff. The axis of symmetry is that vertical line going right through it, and that's always going to be x equals. X equals produces a vertical line. Y equals produces a horizontal line. Well, I should say x equals a number produces a vertical line right through that number on the x, and y equals a number produces a horizontal line going right through that y value. So anyways, right here, this x value of the vertex is -2, so that's the axis of symmetry. That's one of the things they asked for. They also asked for range. The range is it's opening up greater than or equal to the k value, which happens to be 0. Okay, you could clearly see that the y value of 0 is where the parabola starts existing, and it does open up. A couple other things we could mention is that the x-intercepts, there's only one x-intercept at the location -2. You could also say that the y-intercept is at +2. Okay. Sometimes you'll have no x-intercepts if it's opening up and above, or maybe down and below. It won't cross the x-axis. Sometimes you'll have two x-intercepts, like if it crosses at 1 and 3, opening up where the vertex is down here. So you get the idea of all that information that I could ask. Anyways, let's jump to number 3. Doing the odd ones, I guess. Number 3. What do you guys say the a value is? Yeah, 1/4 looks like a good idea, right? Now, of course, we could double check that. Now, normally we go 1 over 1 up, but obviously it's not even going 1 up. That's for the a value of 1. 1 over 1 up, 2 over 4 up, 3 over 9 up. But right here, it's not going 1 over 1 up. It's going way less than 1. So that means that your a value is less. And right here's half, and that looks like half of the half. So 1/4 is a good guess. Now, if you actually think about the original pattern, 1, 1, 2, 4, 3, 9, and if you actually tested multiplying those outputs by 1/4, the next one should be what? 2 over, and what's 4 times 1/4? 1. So it should be 2 over 1 up. So if you do go 2 over, do you go 1 up? Yes, it is. So you're absolutely positive that this a value is +1/4. And of course, the hk is the vertex. So that's a +1 on the x and a -2 on the y. So you know that your h is +1, your k is -2. And now you have enough information to plug it into the vertex form quadratic function format. All I do is rewrite it with blank spots. That's the safest thing to do. Then plug in your values. the a value is 1/4, the h value is 1, and the k value is -2. And that's your answer. The only thing that would look different on a multiple choice is they would simplify anything possible. So the plus negative, they would just write that as a minus sign. But this is perfectly fine. That's your answer. That would produce this parabola that's slightly wider than the parent graph, and that got shifted 1 to the right and 2 down. I just mentioned the transformations right there. Let's move on. Number 5. What's the a value right there?
1.
Yep. What's the h value and k value? Anybody? 2, -4. Okay? That's the vertex, 2, -4. So h is 2, k is -4. We're going to plug it into, and when you plug it into the vertex form, use blank spots. And then just simply plug in your values. A value is 1, h value is 2, k value is -4. That's your answer. That's your function, your quadratic function. Wait a minute, I forgot to put the power of 2. Yeah, the power of 2 is what makes it a parabola. If you don't have that power of 2, it's just a line. Anyway, the only thing that would look nicer if it were a multiple choice test and you're trying to find which one's the right function, you probably won't see the 1. It's not necessary to put the 1. And you probably won't see a plus minus. That'll just be a minus right there. The axis of symmetry is x equals 2. And the range is y is greater than or equal to that y value of -4. Or the k value of -4. 7's too easy. That's just a -1 for the a value. 8, we already did something like, well, let's do 8. Why not? So I'm not doing the odd ones. I'm just jumping around here. Number 8, the a value is what? Do I go 1 over 1 up? No, if I did go 1 over 1 up, then my a value would be +1. But it's not going 1 over 1 up. It looks like it's going 1 over and then how much up? Halfway up. Yeah, so a, according to me, according to us, a is 1/2. All you got to do is double check it. Thinking about the original pattern, 1, 1, 2, 4, 3, 9. You have to multiply, if your a value is 1/2, you have to multiply the outputs by 1/2, by 1/2, by 1/2. So if I do go 1 over 1/2, the next one should be, instead of 2, 4, it's 2, 4 times half, which is 2, 2. And it does go 2, 2. So I know, I'm confident that the a value is 1/2. Anyway, the hk, what is the vertex? 1, 0. Okay, so that means that your h is 1, your k is 0. And when you plug it in to y equals a parentheses x minus h close parentheses squared plus k, we plug it in with blank spots so we don't make mistakes. And the a value is 1/2, the h value is 1, and the k value is 0. So what you would see on a multiple choice would be like y equals 1/2 parentheses x minus 1 close parentheses squared. That's it. You wouldn't have the plus 0. It's not necessary. The axis of symmetry would be the line x equals +1, because that's a vertical line that passes right through that vertex. The range is y is greater than or equal to the y value of 0. It starts existing at 0 and it goes above. Or you could look at it on the original equation. Y is greater than, because the a value is positive, and greater than 0, the k value. Okay, so the range is y is greater than or equal to 0. You can see it visually or algebraically. I don't know, this is getting ridiculous. Let's go to number 10. That one looks a little more fun. Or 9. Which one, 9 or 10? 10? 10. All right, so looking at 10, what is our a value? Anybody? Do I go 1 over 1 up? No. If I did go 1 over 1 up, then it'd have the a value of 1. But it goes 1 over 1, 2, 3, 4, 5. So we're going to assume that it's a equals 5. The a value is 5, or 5 over 1. Okay? So we don't see any other points, because if we did modify the pattern of 1, 1, 2, 4, 3, 9, and we actually multiplied by 5, yeah, the first one you're going to go 1 over 5 up, but the next one's going to be 2 over and how many up? 20, right? 2 over 20 up. So imagine that, 2 over 20 up. You're going to be way the heck off this graph. That's why I don't see it. Anyway, the HK is the location -3, -4. So you know your h is -3, your k is -4. And I'm just going to plug it in directly. Y equals, the a value is 5. You have your x minus h squared plus k, and the h value is -3, and the k value is -4. So to make this look a little nicer, you're going to write y equals 5, x plus 3. You don't need the minus minus, change it to plus plus, and then -4 at the very end. Okay, so since this one is very narrow, it got vertically stretched because that a value is 5. Let's ask you something a little more challenging. What if I wanted you to find the y-intercept? Like if I told you, what are the x-intercepts? Well, the x-intercept is at about -1, 2, about -2.1, -2.2, and also at -1, 2, 3, almost 4. So about -3.9 or -3.8, right? Those are the approximations of the x-intercept, where it crosses the x-axis. But if I asked you, where does it cross the y-axis? As a matter of fact, maybe we should write that down right below right here. Let's say y-intercept. Okay, where would it cross the y-axis? We know this is very narrow. That means it's going up really fast. But even though it's going up, it's always going to go to the left and to the right. So eventually it will cross the y-axis. It has to cross the y-axis. How are we going to find out that y-intercept? Anybody? Plug in 0 into x, right? In Algebra 1, we learned that to find the y-intercept, we set x equal to 0 and solve. We're going to plug in 0 and solve, right? Because after all, that's what these coordinates are. If I were to plug in -1, -2, if I plug in -2, I'm going to get out that y value of +1. If I plug in -3, I'm going to get out that y value of -4. The input -3 gives me the output -4. Right? And you could actually do that if you wanted to. You could plug in a -3 right there. -3 plus 3 is 0. 0 squared 0. 5 times 0 is 0. 0 minus 4 is -4. So when I do plug in a -3, I get out a -4. It's pointless to do it algebraically if you could visually see it. But if I'm asking for the y-intercept, which you can't see, yeah, it's a good idea to plug it in and do the math. So I'm going to do this in my head. We're going to do this in our heads. If I plug in 0, it's going to be way the heck up here somewhere. Plug in 0. What's 0 plus 3? And what's 3 squared? And what's 9 times 5? 45. What does 45 take away 4? 41. So we know that the y-intercept will be at 41. Or you could state it as a coordinate 0, 41. The axis symmetry is x equals -3, the vertical line crossing right through that vertex. The range is y is greater than, because a value is positive, greater than or equal to this k value -4. Or you could visually see that it starts existing at the y value -4 and above. Skipping around. I don't know, how about, out of these last 3, which one do you want to see? It's the last one we're doing here. Left, right, or middle? Middle, okay, middle one. So, do we know the a value? What is the a value? Does it go 1 over 1 up? If the a value were 1, it would go 1 over 1 up, but it's going 1 over how many up? 4. So the a value is what? 4. Okay. What is that vertex? That location from the origin, 1, 2, 3, 4, 5, -1. So the vertex is 5, -1, which means that our h value is 5 and our k value is -1. So we're going to plug it into y equals a, parentheses x minus h squared plus k. Notice that, as I said, a, h, and k, I left them blank. We're plugging in that 4 right there, plugging in the h value of 5 right there, k value of -1 right there. And that is our function. The only other thing you could do is change that to a regular minus instead of a plus negative. But that is the function. If I ask you for the axis of symmetry, it's going to be x equals the x value of your vertex, which happens to be 5. Okay. If I ask you for the range will be y is, because it's positive, it's opening up, which means that it's going to be greater than or equal to the k value -1. The k value -1. Obviously, if you have the graph, it's a lot easier to be like, where does this exist in terms of y, in terms of up and down? It doesn't exist at -5. It starts existing at the y value of -1 and above. So y is greater than or equal to -1. Okie doke, guys. I did almost half of it. Let's do the other half on our own. And then the second half of class, we're going to move on to a different concept.